Hello everyone. Let us today talk about circular convolution. Now, the circular convolution of two discrete sequences x1 and x2 n can be represented by this transformation, and the formula for calculation of the circular convolution is given by sigma n small n going from 0 to capital N minus 1 x1 n into x2 m minus n. These double brackets show the modulo operation because the small n will vary from 0 to capital N minus 1. Small n reaches to after small n completes capital N time instants, then it will return back to 0. It will start again back from 0, right? So that is what the modulo operation is, and the index m will also vary from 0 1 2 up to capital N minus 1. So this is the index m. Let us take an example, and I will try to solve that example using this formula. That will make the things very clear for circular convolution. Now let us, because we have to vary the values of m, let us start with the value of m to be 0. Now when m is 0, so the uh, and we are taking for 4 points, the two sequences are of 4 point each, right? So capital N will be 4 minus 1 will be 3, so sigma n equal to 0 to 3 x1 n, and for m equal to 0, it will be, since m is equal to 0, it will be 0 minus 1 minus n, so it will be minus n. So x2 of minus n is basically flipping the discrete sequence around the circle. Let us take the example. Now this is, let us say, x1n. X1n is 0 1 2 3. How these can be represented around the circle is like this: x1 with n equal to 0 is 0, n equal to 1 is 1, n equal to 2 is equal to 2, and n equal to 3 is equal to 3. So that's how we have to move. We have to perform the circular shifts in the anti-clockwise direction. All right, whenever we have to perform the circular shift. Now the x2n sequence is given by, so x2 0 is 4, x2 1 is 5, 6, and 7. So this is, and x2n will also make its circular shift in the anti-clockwise direction. Now for now, if x2, if we have to flip the signal, that means we have to go for x2 minus of n. Then how it will do? We will have, so what is x2 0? X2 0 is 4. We have to flip one of the sequence, one of the two sequences. Either we can flip x1n or we can flip x2n. Let us flip x2n, and x2n will be flipped. So x2 0 is 4, x2 0 will remain 4. Since now the circular shift is in the clockwise direction, so that means this 5 will come here, right, and 7 will go there. That's the basic difference that will come. So x2 of minus 1 will be 5, x2 of minus 2 will be 6, and x2 of minus 3 will be 7. All right. Now for m equal to 0, we calculate the value of y0. How can we calculate? X1 0 into x2 minus 0. X1 minus 0 means it is 0 basically. X1 n, x2 minus 1. These are to be multiplied, and 4 terms will have to be summed. Now let us see in this diagram. This is x2 0 is 4. So x1 0 is 0. So 0 multiplied 4 multiplied by 0 is 0 here. Then this is, let's go to this value. Let's go to x1 1. It is 1. It is to be multiplied with this value. So 7 multiplied by 1 is 7. 12 multiplied by 2 is, sorry, 6 multiplied by 2 is 12. So you will get 12 here. And 5 multiplied by 3 is 15. So total y0 will be 34. Now you have to go for m equal to 1. Since m equal to 1 means 1 minus n. So that means what is 1 minus n will be equal to, how 1 minus n will be done? That means it is minus n plus 1. Minus n plus 1 let us look at x2 minus n. X2 minus n, this is 4 here and this is 7 here. So when we have to perform x2 minus n plus 1, this will go in this direction, right? This 5 will come here, 4 will go there, and x2 3, let us go back. Okay, we can look at here. So 7 will come here, 6 will go there, 5 will go here, and 4 will go there. That's it. That is the shift by minus n plus 1. So x2 of minus n plus 1. So yeah, our x2 sequence will be now this one. And for m equal to 1, this is to be, these are the values placed around the circle. So this is to be multiplied by, this is 5 and this is 0. 5 into 0 is 0. This is 4. 4 into 1 is 4. This is 7 and this is 2. 7 into 2 is 14. This is 6 into 3, 18. So these are added and y1 will be equal to 36. Similarly, we will do for 2 minus n. Again, one more circular shift will be done in the anti-clockwise direction, x2 of minus n plus 2, right? And we calculate the value of y2, so we will get 34. Then we have to do it for m equal to 3. So when m equal to 3, we will again make one more shift and we will ultimately get y3 equal to 20, and that's our final sequence. In the circular convolution, what happens is the length of the output sequence is the same as the length of the two input sequences, right? It does not exceed. But in the case of linear convolution, if let's say L is the length of the first sequence, M is the length of the second sequence, then the overall length of the output sequence will be L plus M minus 1. But in the case of circular convolution, the length of the sequence remains the same. So that's how we can calculate, we can perform circular convolution. Now one more term is left in the basics of signals and systems, which is correlation. Now if xn and yn are two discrete time signals, then the correlation of xn with respect to yn is given as rxy. So this is the correlation factor, correlation coefficient of x and y sequences, and index is L, which is lag indicating time shift. So it will be equal to xm into ym minus L, right? But as cross correlation between two different sequences, in MATLAB command you can implement this. Using this command also you can implement cross correlation in MATLAB also, right? So this is our rxy, which is the correlation coefficient between x sequence and y sequence, and this is how it varies. And we can also write this equation as m plus L into ym. So this gives me the same result. But can I write to ryx? That means y of m x of m minus L, or y of x ym plus L into xm, meaning by whether this is commutative or not. So cross correlation is not commutative. Let me tell you, you can verify this using the examples, no problem. So yn is said to be shifted by L samples. So if you see here, yn, basically we are using index m, but we can write it to be yn for a general case. Yn is shifted by L samples to the right with respect to the reference sequence xn for positive values of L, and shifted by L samples to the left for negative values of, if we use the negative values of L, it will be m plus. So it will be shifted to the left. When we use the positive values of L, it will be shifted to the right. The ordering of the subscripts xy in the definition of rxy, which is the correlation coefficient, specifies that xn is the reference sequence which remains fixed in time, while yn is being shifted with respect to xn. Now mathematically, convolution between xn and hn is given by this formula. Correlation of xn with hn is given as, now we simply replace L by n, and m in the previous formula we simply replace m by k and L by n, m by k and L by n. So if we do that, we get the correlation formula to be Rn equal to xk into hk minus n. So that means, but if we time reverse the second sequence of convolution, meaning by if we time reverse this second sequence of convolution, it will be h of n minus k, right? We end up with correlation. So that means if we time reverse this sequence, we end up with correlation sequence, right? Because if we take minus of n minus k, so it will be k minus n. So this is same as correlation. But if you remember in convolution, we the first step in convolution is folding only, right? And then if we again time reverse it, we will get the correlation, right? Now correlation mathematically is just convolution with the second sequence time reversed, right? That's what we have seen. We can use this property to find correlation using the same method we use for convolution. The second sequence needs to be time reversed. If the second sequence needs to be time reversed, then we are one time folding, time reversing already in convolution. So meaning by, let us not time reverse for convolution in the first place. So what I mean to say is that how convolution is different from correlation. Convolution involves the flipping operation. Correlation does not involve any flipping operation. Now let us take an example. Let's say we have two sequences, 3, 1, 2 and 3, 2, 1. So these are the two sequences. So xm is 3, the origin is 0, right? This is m index. It is 3, 1, 2. And what is ym? Ym is 3 to 1. So we can put it here, 3, 2, 1. So if we take ym plus 2, so that means this 3 will be shifted to the left by 2 time instants. So that means the 3 will come here, 3 to 1. So that's the sequence. Ym plus 1 will be 3 to 1. Ym will be 3 to 1. Now what is ym minus 1? So it will be shifted by 1 time instant to the right. So I have put every ym minus 1 also, minus 2 also, minus 3 also. The value of m starts from minus length of y. What is length of y? It is 3. Minus of this is minus 3 plus 1. So that means the value of m will start from 2, which is minus 2, and continues till length of y plus length of x, 3 plus 3 minus 1, so 5. So that means this continues till 5. So these are the m values. It starts from minus 2 and it should end at 5. That will be your whole sequence, correlated sequence. All right. Now let's calculate the values. Let us calculate the first value, rxy minus 2. So we will take ym plus 2 here. So this 3 multiplied by 0, 2 multiplied by 0, but 3 will be multiplied by 1. So it is 3. Everything will be 0. So rxy minus 2 is 3. Rx minus 1 means uh, this is ym plus 1. So 3 will be multiplied with 0, 3 will be multiplied with 2, and 1 will be multiplied with 1. So it will be 7. So in this way, you have to go for rxy 0 also. So 3 goes with 3, 2 multiplies with 1, and 1 multiplies with 2. Answer is 13. So in this way, if you repeat for all the values, so you get rxy 1 also, rxy 2 also, rxy 3 also, right? So no overlap is there. So this is the output sequence, 3, 7, 13, 7 and 6. This is the correlated sequence of the two discrete sequences, right? So that finishes the topic on circular convolution and correlation. Thank you.